There are some questions that you come across in your paper that are actually quite fun. They've got a bit of a story to them. You've got a runaway train rolling down a hill that crashes into something else, or like the example that we looking at. Well, here's a little clip to give you a picture of what is going to happen.
That close one. Huh?
Watch out for that tree!
Oops.
Watch out for that tree, indeed. Well, we're going to look at the original dude who kept swinging from trees, Tarzan himself. He was actually starring in a 2009 paper. As you can see, this question number 6 here. Let's read it through. Tarzan of mass 80 kgs, a little piece of information there worth underlining, swings from rest, also helpful, on a rope of length 10 meters. That is horizontal when he starts, as shown in the diagram below. At the bottom of his swing, so when he gets to the bottom of his swing, he picks up Jane, sitting on the ground. She's just sitting there, so that's a helpful piece of information, at rest, in an inelastic collision. Yo, that's got to hurt. Jane has a mass of 50 kgs, and then they swing upwards as one unit. The mass of the rope, the effects of air friction may be ignored. So, state the principle of the conservation of a linear momentum in words. Nice, easy, low-hanging fruit just to get us started. Definition, you can nail that one. What we're interested in is 6.2. Calculate the combined speed of Tarzan and Jane just after he picks her up, for a whopping 8 marks. Okay, so in an exam situation, obviously, we'd read it through again, just make notes of certain things like your VI equals naught, etc., and so on. And then we've got to try and process, well, we've got a lot of information going on there. How do we work out what goes where and who goes what? So, diagram. Remember, 3Ds, key step is to draw a good diagram. Now, you, of course, could annotate what's there. I've just made a very simple, similar looking diagram like this. So we've got Tarzan up in the tree at rest, and Jane waiting down on the ground, eating her pineapple or whatever it was before she got rudely interrupted. So the key thing is our thinking around our story, because it wasn't a simple story. It wasn't just one thing. There were a couple of chapters to this story. So breaking down the chapters is important. The first one is the swing itself. Tarzan swinging down from the tree. Now, this is classically a closed system. There's no friction, we've told that. There's no applied force. Energy principles can apply. We're looking at the conservation of EMEC for chapter 1. Then, Jane gets picked up. We have a collision, therefore, conservation of momentum. It's a different part of the story. Okay, so you can't use the same principles in both. It's now you're going to move into a different chapter. And then, if we needed it, which we don't in this particular case, but chapter 3, they swing off up into the sunset together, and once again we're back to the conservation of EMEC, closed system and all. Now, in our calculations, the trick is getting good linkage between the different chapters. We've got chapter 1, Tarzan swinging down, okay? That's going to be EPI plus EKI and all that kind of thing, and that's going to lead us to the point where we end up calculating his velocity, his final velocity. Okay, that is going to be at the end of chapter 1. Now the linkage is obviously that what ends in chapter 1 is now going to be the start of chapter 2. So VF of chapter 1 becomes our VI just before he collides with her. And that's when we're going to get into momentum. So linking each chapter to each other is really where the magic happens. And that's why it's an 8-mark question, because you've got to find one thing, use that to find something else, and so on. So that's about it. I think it's up to you now. No more hanging around, as it were. It's time for you to get on with some practice. Cheers, man. Bye.